about the hemispheres. So about the hemispheres, on the real brain we'll see the hemispheres. We know that we can divide the right and left hemisphere, and we can divide three surfaces of each of the hemisphere: facies superolateralis, facies medialis, and inferior. Both hemispheres are divided by the fissura longitudinalis cerebri and fissura between the cerebellum and inferior surface, fissura transversa cerebri. Those we'll see on the brain. We'll see. Now, about you have to know the main sulci and the main gyri. Okay, but this part is quite easy, I guess the most easiest part of all the brain. So, as well as you have to remember at least the main centers which are represented on the main gears. So, who wants to present us the facies superolateralis we have here? What kind of main sulci we have there? So, who will be the first?
Telencephalon.
So you can go there and show us.
9.
9. Yeah. Okay. So nobody.
Maybe the Telencephalon is next to the centralis, like the first.
So you will.
No,
tell
it's
us.
like the only one I would guess.
But this part is the
Centralis,
easiest
postcentralis.
part of the brain. So you can try. Okay. Do we have a sequence for it? Yes, we have. So this is sulcus centralis. Precentralis. Superior and inferior.
And then in lobus parietalis, you've got sulcus postcentralis, which is that one. And sulcus intraparietalis, is that this one?
This one.
And then you have in lobus temporalis, you've got sulcus temporalis superior, which is this one.
This is intraparietal.
Temporalis superior.
This one.
And temporalis
Inferior. And one very important sulcus. So you can have sulcus lateralis.
Oh yes, sulcus lateralis.
Between the frontal and the temporal. This sulcus. Yeah. And we have we have three main sulcus. Sulcus, you mentioned sulcus centralis, sulcus lateralis, and sulcus parieto-occipitalis, which is more visible on the medial surface. It is here. Separate the parietal lobe from the occipital lobe. What about this sulci? Okay, that was the easiest part. Let's start with the gyri of each lobe. So, and if you will have the question or in a colloquium, or actually I have already the questions of colloquium. description of the lobus frontalis. So, at first you have to mention, not to start with the, oh, there is sulcus that, sulcus that. Absolutely, sorry, bullshit. You start with the elementary, how I have taught you. What is this? You explain to the person who doesn't know anything about that. You start that this is one part of the telencephalon, one part of the pallium. It is on the both sides, separated by the sulcus centralis from the lobus parietalis, by the sulcus lateralis from the lobus temporalis. It consists of the white matter, which is covered by the grey matter. And there is sulci and gyri, and then you describe main sulci into the frontal lobe. And if you have the frontal lobe with any description or superolateral or medial surface, then you have, if you have only this frontal lobe, do not forget the medial surface as well. Usually students describe the superolateral surface and they forget that there is a medial surface as well. So, we have the frontal lobe above the gyri. Yeah, you can try. Usually those parts you present here in front of the group, those parts you usually know the best. When you will describe in colloquium or exam, you will describe between each of the sulci lies each gyrus. Yeah? As we see now, or you draw the drawing, and of course you mention all the sulcus, all the gyri, and of course it's visible, and you do not write the text about the drawing you have just drawn.
And gyrus frontalis inferior is
inferior. Frontalis inferior. Okay. What kind of functions the main gyri has?
I don't know yet.
So, who can help?
Speech and
Gyrus precentralis, very important part. Actually, if you talk about the gyri, you have the talk about the main centers which are into the each gyrus. The main gyrus we have to know. So, what is about the gyrus precentralis? It's a motor sensor, primary motor center, from where we already know starts which tracts? Tractus corticonuclearis, then corticospinalis, corticopontinus. All this gyrus is represented by the different parts of the body. If we cut the, so here we have the and you have gyrus precentralis on the facies superolaterales. If we cut it, of course the gyrus lies on the medial surface as well. All this cortex with different layers of the cells, and the main cells are pyramidal cells, which form those tracts by their axons. But the different parts of this gray matter of this gyrus precentralis represents different parts of the body. So that means if we want to move the hand, the impulse will go from this part. If you want to move the face, tongue, it will go from this part. So, and this map, where we can see the centers, so the parts which are represented on the gyrus precentralis, this map is called homunculus, motor homunculus, and it looks like that. It is the frontal or coronal section of the gyrus precentralis. So you see the most parts are filled with the cells which gives the impulses to the arms, to the face, tongue. So the trunk and the lower limbs as the smallest parts. That was about the gyrus precentralis. So then we have on the frontal lobe, we have gyrus frontalis superior, we have gyrus frontalis medius inferior. On the gyrus frontalis, things you have to know. On the gyrus frontalis medius, what kind of centers we have there? Writing and drawing center. Writing and drawing center. Here. And on the gyrus frontalis inferior, motor speech center, which is called Broca's center. Is it mentioned in those materials which differs? Yeah. Broca's center at approximately here. And what kind of speech, what kind of speech will have the person if this area is damaged? So they understand the questions, they understand the words, they can read, they understand, but they cannot answer. They cannot form the very complicated sentences. So the sentences consist of 2-3 words. We call this speech telegraphic speech. So, therefore this calls the center of the motor speech, because we have to speak and then we have to understand the speech for others. So that will be another areas we'll discuss later. So 3 main centers you have to know into the lobus frontalis. Okay, who will be the next? Yes, about the, you can choose which. Okay, lobus parietalis.
Sorry. Yeah, on the lobus parietalis we have the gyrus postcentralis, which lies approximately here behind the sulcus centralis. And then we are having the lobulus parietalis superior, which is here the superior part, and the lobulus parietalis inferior, which is here this inferior part. And this lobulus divides again into the gyrus supramarginalis, which is approximately here in this region, here, up here.
Supramarginal, this is here.
Or in this region, and then we have here the gyrus angularis, which would be then here, in this region, I think.
Yeah, that's right.
Yes.
Then the functions of each those you mentioned parts.
Functions are, I don't know them.
So
Reading center.
So which is reading center?
The gyrus angularis.
Angularis. Then gyrus supramarginalis.
Supramarginalis would be for sense and touch. No, that's postcentralis. I don't know.
That
Doesn't
wasn't
say.
mentioned there?
No.
Okay. Then you those centers who are not mentioned there, you do not have to remember, of course, because the actually the frontal lobe are responsible for the intellectual ability of the person. And actually the left lobe, or the left hemisphere of the brain, represents the emotional part, emotional reaction of the person, left hemisphere. Right hemisphere represents the logical thinking. And it is evidence-based conclusions that each 1.5 hours, they change their dominance. So, that is interesting, talking about the many different situations when you talk to persons, and actually sometimes they understand you, sometimes they do not understand, because you do not know which hemisphere dominates at that moment, or the logical, or the emotional part, or the left hemisphere. So therefore, sometimes you can get the different reaction from the persons. Yes.
Which part there was a lobotomy to me?
Lobotomy means to extirpate or take out one part of the lobe.
I think there was a former therapy.
Yeah, because it depends on what kind of problem we have. Sometimes it can be in epilepsy. We can remove some parts as well during, according to the different other illnesses like the tumors as well. But one more thing, that will be the white matter topic we will discuss later, as we have both lobes, the right one and left one. Between the between the hemispheres we have the communications. Neurofibra commissuralis. So, and then this is as well evidence-based that those communications between both lobes, both hemispheres, the female persons have much more than the male persons. So that means the conclusions could be that for the female it's easier to change. They can change the dominance between one or other lobe according to the situation. For the women, it could be easier. So that is some literature conclusions I have read. So maybe you can do the other science, you will get another conclusions. Okay. About the parietal lobe, so center gyrus postcentralis.
Which one?
There we have gyrus postcentralis. We have the sensory cortex, where we receive the information from the sensory conscious pathways from the tractus bulbothalamicus, lemniscus medialis, and all other tracts which joins to all this, and they ends into the gyrus postcentralis. Into the gyrus as well. The gyrus postcentralis has the same homunculus according to the sensory part. So the most sensory parts of the conscious sensory things we have on the hands, face, and all these parts which are represented here. So the lower limbs and the trunk are not so large expression into the gyrus postcentralis. So this homunculus we use for the sensor and motor centers. About the lobus parietalis, we have as lobulus parietalis superior inferior here, and two are supramarginalis and marginalis. We already discussed that angulus is the reading center. And all those angulus gyrus supramarginalis and as well some parts of the gyrus angularis, they coordinate and regulate very purposeful and complicated movements. So those persons who has a occupation due to movements, for example.
Pardon? Or what was the question?
So this center coordinates and helps to provide the movements, very complicated, very purposeful movements, and which occupations or which persons need very complicated, purposeful movements? Sports and dancing as well. So, and that was about the parietal lobe. Then we have temporal lobe. Okay. Wernicke's center, and how it differs from the broadcast center.
Problem is that if you have a damage there, that you can grammatically speak normally, but it doesn't make sense.
Yeah, that means you do not understand the other speech. You hear the words, but you do not understand. Because you have a question from the person about anything, but you answer about absolutely different things because you do not understand the speech.
Can I ask a question? Does that mean that the person with the Wernicke's aphasia has the problem with understanding it, or the other person can't understand what they've said?
No, your speech is absolutely normal. You ask me what is my name, I will tell you the next time you will have to read about that and that. Because I do not understand your speech.
Oh, you didn't understand what I said?
Yeah.
Okay.
I can form normally grammatically sentences. Because if my broadcast center is not damaged. So I cannot understand the speech. Sometimes children do not understand anything the parents say. But they have absolutely normal Wernicke's center. They do not want to understand. But if you ask about the ice cream and chocolate, they understand. Yeah, sometimes because parents say that there's something wrong about the hearing of the child. Because they always say something and they do not hear, they do not react. But then you can ask, do you want some sweets, ice creams, or look cartoons all the day? They hear it after a few seconds. And they agree usually. Okay. That was about the gyrus temporalis superior, and then we have
the gyrus temporalis medius
Mhm.
here, and this part for the balance pathway.
for the balance center.
Right.
Yeah.
And the gyrus temporalis inferior.
Okay. And then we have the parietal lobe. And what do we have on the parietal lobe? On the superlateral surface. On the not parietal, occipital lobe. We have small gyri and sulci occipitalis. About the centers in the occipital part, we'll talk about the medial surface. Okay, thank you. Next one. About the medial surface. Beatrice?
Don't destroy my movie.
Do not destroy the movie. Okay. So, who will be the next? Always pretending that something reading and are so busy with the materials. So, Maximilian? Mark?
Are we just supposed to say where the sulcuses are, or?
Where are the sulcuses?
I could try the first part, the first.
Okay, we have on the medial surface corpus callosum. We have sulcus corporis callosi, which continue into the sulcus hippocampus. Then we have sulcus cinguli, which actually in some and on the natural brain it gives it continues. Maybe some interruptions can be here, but it gives the two branches. Anteriorly, this is the sulcus paracentralis, and posteriorly no, marginalis, this one. You do not have?
I don't think it says.
Ramus marginalis, you don't have?
I don't think so. It says?
Then we have sulcus parieto-occipitalis, which separates the parietal and occipital lobes. In the occipital lobe, on the medio-inferior surface, we have sulcus calcarinus. Posteriorly, to the side of the lobe, around the sulcus calcarinus, we have the cortical centers of the vision. And if you have a trauma, damage the occipital region, the first thing is you can lose the vision. Then we have gyrus ovis.
In this one, did you say we're subparietalis? So subparietalis?
This one, sulcus parieto-occipitalis.
No, not parietalis. The one before that is subparietalis?
It can be here. but not always this is shown on all drawings. I have this drawing so it can be here.
So that section of the
And then we have the gyrus, the main gyrus of the medial surface. We have
Singly?
all these gyrus together we call gyrus fornicatus. Then we have four parts. Gyrus singuli, this one. Isthmus, narrowing of the gyrus. Isthmus gyri singuli. This one, posteriorly to corpus callosum. Then we have this part, gyrus parahippocampalis, and ends with the uncus, the cortical center of the smell. Which structure connects subcortical centers of the smell, corpora mammillaria, with the uncus? Fornix. Yes. And deeply to the sulcus hippocampi, here we have this blue colored, this is gyrus dentatus. That will be about the medial. Then we have, of course, the on the temporal. Of the frontal lobe, we have gyrus temporal, gyrus frontalis superior inferior, and the precuneus, cuneus. This part belongs to this is lobulus paracentralis. So this is continuation medially of the lobus of the gyrus precentralis on the superolateral surface. Gyrus precentralis. Medially, we call this gyrus lobulus paracentralis. Here. Okay, on the medial surface, the main things we have here. Then, that you know, and that is how on the natural brain the medial and inferior surface. You already recognize those things. We have corpus callosum, lamina rostralis, have lamina terminalis. This is hypothalamus. Here we have sulcus hypothalamicus, thalamus, adhesio interthalamica, aqueductus cerebri, pineal gland, of course, corpora mammillaria, tuber cinereum, infundibulum. Usually, when the brain is removed from the skull, hypophyses stay in the fossa hypophysalis. It's very difficult then remove. Then we have, at first, when we remove the brain, we have a little bit damaged the sella turtica to get the hypophysis together out with it, because the infundibulum is very thin and hypophysis quite sometimes more than approximately 1 sometimes centimeter in wide. So therefore it usually stays into the fossa hypophysalis. And you recognize the mesencephalon with substantia nigra. And this around the thalamus, and which goes here, is the fornix from the corpora mammillaria to the uncus. The sulci, here we have sulcus corporis callosi, sulcus singuli, gyrus
Frontalis.
cornicatus,
Ah.
with the gyrus cinguli, isthmus, gyrus parahippocampalis, and uncus. This is sulcus parieto-occipitalis. This is ramus marginalis, and this is sulcus paracentralis, lobulus paracentralis, and this is precuneus, cuneus, and this is sulcus calcarinus, this line. Sulcus temporalis. Sometimes it's very difficult to recognize the many things we see on the drawings because each brain, of course, differs. When the baby is born, they have absolutely smooth surface of the brain. Why? Smooth, absolutely smooth.
So the bones can actually move a little.
And why the brain becomes with the sulci and gyri during the life?
Because of the development of the different arteries and so on.
A bit louder, No, maybe it was right.
Probably not.
Probably not, or maybe yes. Because baby borns with, of course, some information, but this is still enough in the smooth brain. And then they learn all the time many things, and then we have space to put somewhere all this information, therefore they form the gyri to enlarge the surface of the cortex and where to put all the information.
Fantastic.
So that was about the cortex, about the hemispheres, and then we have the inferior surface of the brain. And now we can see a little bit from the Telencephalon. This is a part of the smell pathway. Belongs to the hemispheres as well. And here we have on the inferior surface of the frontal lobe, we have sulcus olfactorius, if we remove this structure. Between the fissura cerebri and fissura longitudinalis cerebri and sulcus olfactorius, we have gyrus rectus. Into the sulcus olfactorius lies bulbus olfactorius, the anterior part, which continues into the tractus olfactorius. And here we have the tractus olfactorius enlarges, becomes flattened, and we call it trigonum olfactorium, like a triangle. Communicates with the substantia perforata anterior here. Here is covered by the hemisphere, the temporal lobe, anterior part. Of course, we'll see the. I will check. Do you need to know to the colloquium this semester the olfactory pathway? So therefore, I'd like to say some words. We have the olfactory pathway. So here we have the bulbus olfactorius, tractus olfactorius, and triangle, trigonum olfactorium here. This lies on the skull into the anterior cranial fossa, and bulbus olfactorius lies on the lamina cribrosa. As you remember, we have the small openings into the lamina cribrosa, and through the lamina cribrosa openings, the nerves from the olfactory parts of the nasal cavity by the axons goes to the through the lamina cribrosa to the bulbus olfactorius, and then the smell pathways continues into the way I just showed you. So one more time: chiasma opticum, nervus opticus, tractus opticus, corpora mammillaria, tuber cinereum, and the infundibulum with hypophysis is removed. Very nice drawing view of the pedunculi cerebri. Substantia nigra, descending tracts, and here you have nucleus ruber. Aqueductus, tegmentum, tectum mesencephaly. Closer, here we have bulbus olfactorius, tractus olfactorius with the triangle, trigonum olfactorium, substantia perforata anterior, fissura longitudinalis cerebri, gyrus rectus. Okay, and then we should talk about the white matter. The white matter of the hemispheres, you know, we can divide into 3 large groups. Associative fibers, which connects the different parts into the region of the one hemisphere, and therefore those associative fibers, we have 4 parts. We have fasciculus longitudinalis superior, inferior, fasciculus uncinatus, and cingulum. And those associative fibers which connect the grey matter into the area, into the one lobe, or even into between the adjacent gyri, we call fibrae arcuate. Those are fibrae arcuate in this drawing. Those are associative fibers. Then we have neurofibrae commissuralis. What type of 3 groups we have? Corpus callosum. Then commissura cerebri anterior, and formis. Commissura formis is only one part. Neurofibrae commissuralis. Let's repeat about the corpus callosum. You recognize the corpus callosum with the splenium, with the truncus, central part, and genus, with the rostrum, lamina rostralis, lamina terminalis. Then, that's about corpus callosum. Here is removed corpus callosum. On the real brain, we'll see that the corpus callosum is on the white matter, which lies on the on the horizontal plane structure, which connects both hemispheres. That is the part of the description of the neurofibrae commissuralis. They connect the identical parts of the cortex between two hemispheres. And you usually see the corpus callosum in the sagittal section, and you see that it looks like that. But you have to imagine that it is, if it's not cut, it lies on the horizontal plane and can connect both hemispheres, and it lies like a bit curved around the thalamus. And when we remove the hemispheres, the first thing we see is the corpus callosum. That we will see on the natural brain. That is the corpus callosum. When we, this is a cross section or horizontal section of the brain in the level of corpus callosum, a bit inferiorly, and the anteriorly, posteriorly, those fibers form the, how we call these, forceps cerebri anterior, posterior. Yeah. This is what is this? Fissura longitudinalis cerebri. Does everybody understand which view is this of the brain? This is the view when we cut the brain horizontally, move upper part, and we see then this slice of the brain. About other structures we see here a little later. And then we have neurofibre projectiones, which connects the cortex with the lower located structures, subcortical structures, and structures into the spinal cord. And the main structure belong to the neurofibre projectiones. This is white matter, do not forget, is capsula interna, which lies laterally from the corpus nucleus caudatus. You see nucleus caudatus here. This is the same view when we cut horizontally the brain, remove upper part, and we see on the lateral view this view. Nucleus caudatus, thalamus, superior, medial thalamus. Actually, superior will be that one. So this is medial, surface medial part of the thalamus. Laterally, thalamus connects with the capsula interna you see here. And to the capsula interna go the different tracts, and they have certain location into the going through the capsula interna. So you see this drawing, but you have to understand that the tracts goes. This is the horizontal view. This is horizontal section. We see this view when we cut and see, and the tract goes. We see capsula interna like that, but tracts will go, of course, that way, through the capsula interna.